So now let's look at the data. I'll kind of give you an idea for why I recommend towing the speaker out, some of the things that I heard when the speaker is aimed directly on axis, and a little bit more information about the bass alignment. This is the impedance, and you can see that it's a nominal about 3.2 ohm load above 80 hertz, and the minimum EPDR reaches down to 1.9 ohms. So I would recommend that you use a 4 ohm stable amplifier. A standard AVR probably just isn't going to do the trick for this particular speaker. This is the frequency response on axis aimed directly at you, the listener, in red, and in black is the frequency response towed out about 10 degrees. And you can see that towed out about 10 degrees, there's a drop in this higher frequency. And you may say, well, I don't really want that. And I hear you. But in my listening, which I did before I even looked at measurements, before I even put the speaker on the Klippel near field scanner, which is what I use for all of my measurements to give me anechoic data, I had made a note that the speaker sounded a bit bright. And that wasn't a far cry from what I found when I looked at the data. There's a little bit of a bump in the treble there, around about 9 kilohertz or so, and it's elevated right through there. Now, that elevation in and of itself isn't really an issue, but thanks to, which sounds odd, but thanks to the constant directivity of the tweeter and the waveguide of the mid-range, that elevation stays true as you go into the room. So that particular response stays solid throughout all the angles. What you need to do in order to knock that down and make the in-room response more neutral is to just tow the speaker out. And when I talk about in-room response, this is the example. Black is 10 degrees off axis, red is 0 degrees directly on axis. And you can see again that the red shows a little bit of an elevated treble. And while that's only about 1 to 2 dB difference, it's audible. Now, if I draw a trend line through this response, you can see going through the mid-range and the upper mid-range and lower treble, that trend line matches both speakers well, but around about 4 kilohertz, that on-axis response in red flattens out. So that causes the speaker to sound maybe a little bit bright than it would if you towed it off axis. You can possibly remedy this by using some room treatment or some wall treatment to help absorb the high frequency reflection, but I honestly don't think I would recommend doing that. Just towing the speakers out a little bit makes the difference. Do that. This is the linearity of the speaker when positioned 10 degrees off axis. You can see the overall sensitivity is at about 86 decibels. Its F3 is at 76 hertz and its F10 is at 37 hertz. Now look at this low end bass. Ain't that funky? This is called an extended shelf bass response. This is generally done to match typical room gain. So what you wind up with in the room is a more neutral response rather than maybe a boomy response. Now, this is going to be room dependent and it's going to be placement dependent, but it actually seems to work quite well in my room because the bass did well for all of my music down into about 50 hertz. I didn't really have any problem with kick drums like I've had out of a lot of speakers recently. I liked the bass response out of the speaker. Again, would have been great if it would have gone down to 30 hertz or 40 hertz. It didn't quite do that, but it was enough to capture most kick drum and most music that I enjoyed. This is the Spinorama data, and I mean, this looks really great, y'all. I pointed out a few different things here. Class-leading directivity and sound power. The sound power response is really good, very neutral, if you want to call it that, quite linear. The on-axis response at 10 degrees, so the 10-degree response, is also quite linear, which we already saw. And the early reflections directivity index down here in the dash blue is also quite linear, which means that this speaker will take very well to equalization should you find that you want to change the tonality or the timbre to suit your own liking for whatever reason. This also means that in a room with multiple seats, you're going to have really good response between all the seats up until about 4 to 5 kilohertz, where the high frequency is going to roll off a little bit more, and that's going to be more seat dependent. But most of your listeners, if they're sitting off axis, are probably watching a movie. So you're probably using a center channel, so it's probably not that big of a deal. But this still matters to me because I don't sit with my head in a vise. I mean, moving a few inches one way or the other, or up and down, is very common for me when I'm listening to music, or if I want to lean over and get a drink or something like that. I don't sit all stoic. I just don't. It's uncomfortable. I feel like I'm not even listening to music anymore. I feel like somebody's watching me, and if I move, I'm gonna get smacked upside the head. So I like having a speaker that has a broader horizontal response and a broader vertical response because that opens up that sweet spot. You don't have to sit in one deadlock position. You're free to move a little bit around in that seating area, and you're not going to change the overall sound of that speaker. This is a horizontal radiation pattern. And I just wanted to note that this does narrow up in frequency. It's very similar to the R3 regular one, so the non-Meta R3 that has been discontinued now. The radiation narrows from about plus or minus 70 degrees to about plus or minus 40 degrees from low frequency to high frequency. This is the vertical response. 0 degrees right here is your reference axis. As you go above and below that reference axis, you can go as much as plus or minus 20 degrees and even as much as plus or minus 30 degrees, and you're going to have roughly the same sound characteristic, which goes back to what I talked about earlier about sitting in a sweet spot. There really isn't a deadlocked head in a vise sweet spot with this particular speaker. You can move around. Now, I'm not saying you can get up and move 3 feet to the side and it's going to sound the exact same. It doesn't work like that. And stereo itself doesn't work like that. You've got level and time differences that are going to affect the sound more than just the overall timbre of the speaker itself. But within reason, if you move a few inches one way or the other or up and down, the speaker is going to sound the same. You're not going to see this kind of vertical response from a standard 2-way or a standard 3-way design. I've never seen a 2-way or a 3-way design come close to matching what a concentric speaker can do, at least as long as it's a well-designed concentric speaker. And that's what we have here. Now let's talk about output capability. This is the harmonic distortion at 86 decibels. We don't cross 3% THD until about 40 hertz. And then at 96 decibels, we cross 3% THD at about 80 hertz, and then it dips down again around about 50 hertz. So this kind of tells me that you're going to start running out of steam at higher output levels. You're probably going to want to use a subwoofer unless you're sitting close to the speaker. This is the multi-tone distortion, which is a great way to tell, all right, what's it going to sound like with music? Is there going to be audible distortion? And this line that I have for 3% is usually my personal metric. So if it's above that, I'm going to say, yeah, you might want to maybe reconsider or look at other options because you might hear distortion with your music if you're listening at high output volume. This particular speaker, I don't see that. We see a couple spikes here or there, but those to me are in the noise, and it's also very high resolution, so I'm not really worried about that. I'm not doing live, so. Oh, cool. Thank you. Random. My kid just popped in and gave me a ring, y'all, for Father's Day. She made this out of resin. All right, so back to the review. What happens when you apply a crossover to the speaker and then play multi-tone distortion music or multi-tone signal through it? This is what happens. The distortion goes down. So I'm going to compare it again to full range and then with a limited bandpass of 80 hertz and above. It doesn't change a whole lot, but it does change, which indicates that yes, using a subwoofer and a proper crossover is going to help this speaker give a little bit more dynamic range, which we'll talk about now. This is the compression linearity dynamic range graphic that I provide. All these lines should be stacked up on top of each other if this is the world's most perfect speaker. It's not. It's a standard loudspeaker that's going to have its standard issues. So that means that below about 100 hertz, we start seeing wild deviations in the response profile at the highest output levels and at 96 decibels and even at 86 decibels. Now this graphic doesn't look great, but if you go back and compare it to other speakers in the same price category of the same size roughly, you're going to find they all share something similar. And some of them are worse and some of them are a little bit better, but they're all generally in this ballpark. So this data coupled with the distortion data tell you use a subwoofer. You want to keep the speaker from overexerting itself or running into high amounts of distortion, use a subwoofer. Otherwise, don't listen at really high volume and or listen a little bit more closely to the speaker. I mean, physically closely. In other words, if you listen to the speaker from 12 feet away and you're trying to get it to do 100 decibels, it's not going to do it. But if you're listening to the speaker from about maybe 10 feet away and you're listening to it on average at about 75 to 85 decibels, and every once in a while you hit a peak at around 90 something decibels, you'll be fine with the speaker. Let's talk about sealed versus ported configuration real fast. I did measurements of the speaker in sealed configuration, which is what you see in the orange graphic below, and black is the ported configuration. So you can see the difference in response here, that the sealed rolls off at around, let's say about 100 hertz, where the black starts to roll off at around the same frequency, but then it's got a tuning a little bit lower in the port that allows it a little bit more bass extension. Listening back and forth between the two, I preferred listening to the ported configuration. It just made more sense for me. It got lower, and I wasn't using a subwoofer with this speaker when I was doing my initial testing, so ported made more sense for me. But you had the option to do either one.